a heads up on what tonight's going to be about?
So we're going to be covering quite a few things tonight. So we're going to be quite nippy and nappy through it. We're going to be talking about SpaceX's latest endeavours, a wonderful new asteroid finding by some school kids, which is quite cool. Bits on the Beetlejuice story with dust, the Arecibo radio telescope. We're just going to cover quite ingenuity, yeah, what it's doing on its way to Mars. So there's quite a few little things that we're going to kind of blitz through, and if anyone's got any questions at any point, please put them in the chat. We're more than happy to answer any questions at the end if we've got time. If not, stick them on YouTube in the questions and comments there. Obviously you can post to either myself or Terry on Twitter. We're both quite prominent on Twitter, so more than happy to get into any debates and discussions. And also obviously at Space Store you can communicate any of your comments, thoughts through them as well, and we're more than happy to take on any comments that you may have.
Definitely. Well, let's get going then. Once again, a very warm welcome to everyone joining us on YouTube for another Space Store Roundup, where we bring you the latest and greatest of space news. I'll be back in around 25 minutes for a short Q&A. Hopefully there's some questions. Please do, as Nick said, leave them in the YouTube chat under the video, and we hopefully can get to them at the end. I hope you guys have a great one, and I'll see you shortly.
Cheers. Well, our top story to this week, it had to be. Obviously, SpaceX have been very busy of late. They launched some Starlinks earlier today, which every astronomer in the world loves, of course, because it's our favourite thing. Light pollution, vermin in the skies. But as I've always said, and I know Terry feels the same, we've got a kind of a love-hate relationship with SpaceX and Elon Musk. On the left hand, phenomenal. What he does with the Falcons, Falcon Heavy, etc., really brilliant. On the right hand, Starlink, everybody hates it. Anyway, but this week they launched the grain silo. So what you can see on screen is a massive incarnation of their space hopper. Not the bouncy things that we all used to knock around on in the 1970s. This is literally the size of a grain silo, powered by one of SpaceX's remarkable Raptor engines. So this is a kind of precursor test to Starship. So Starship's going to be a 390-foot high, so bigger than the Saturn V behemoth, capable of lifting about 100 tons, metric tons, into low Earth orbit, and obviously more than capable of getting to the moon and to Mars. Musk has got these long-term intentions to put potentially up to 100 people in one of these for a Mars mission. It'll be hitting the Martian atmosphere at 7.5 kilometers per second, something that big. So we're looking at a spacecraft landing on the surface of Mars. It's potentially going to be about 150 feet or around about 50 meters high. So these tests are really important. The Raptor engine tests and the ability to gimbal these engines, independently gimbal up to 31 of them, which is what they're planning on Starship, is going to be really important. The SNs, as they're known, is kind of like a test module for this out of Boca Chica in Texas. He's not had a lot of success with some of them. Some of them have blown up during the pressure tests. Some of them have blown up during the engine tests. But this one flew. And it was really amazing watching some of the YouTube reactions from some of the live streams who were covering this. And it was like watching grown men turn into excited little schoolboys. It was brilliant. But it really did. It flew up to about 500 feet in the air. Performed a sideways maneuver, deployed its landing legs, which you can see in the picture there, landed in a cloud of dust using this gimbaled Raptor engine, and it was pretty flawless. It was about 47 seconds, I believe, total duration. I watched it live. I don't know if you did, Terry, but it was a heck of an achievement.
Yeah. It's not the most beautiful thing you'll ever see, but of course, when it's finally in its configuration, it'll be sort of streamlined fairing and so on. As you say, at the moment, it looks like a gigantic grain silo, but the important thing is that it did actually work. And you can't say anything about Elon Musk that he doesn't have ambition. I mean, for a private individual to be at this stage of developing something that is potentially capable of taking people to the moon and Mars is really remarkable.
That's it, and the confidence he's been shown by the likes of the US Defense Department, DARPA, and NASA, obviously, with the perfectly executed SpaceX mission, apart from obviously the splashdown where they were surrounded by boats, and there's issues that they're trying to resolve on that. But everything else he's doing, as Terry said, it's kind of, he doesn't shy away from challenge. And if you think that between SpaceX and Blue Origin, they kind of started almost in parallel, and Virgin Galactic, it was almost like a three-pronged approach to spaceflight between human spaceflight and robotic exploration. And he really is so far ahead of the rest now. I mean, today's SpaceX launch with Starlink, despise it as I did, you have to admire the fact that, again, they nailed the landing on a barge in the middle of the Atlantic with a heavy sea state, and also managed to capture at least part of the fairing in a net. I mean, that's just remarkable levels of precision when you're coming in from orbit at extremely high speeds. Obviously, and they're doing their landing burns and their deceleration burns as they're coming back through, but it's something to watch. And I would say, I don't know if you're feeling the same, Terry, with his current trajectory, if he carries on with the pace of testing, I would probably say that we would see a full stack Starship launch, at least a low Earth orbit, or potentially a circumlunar mission, probably within the next 3 years.
That's ambitious, but provided there are no hiccups along the way, yes, it'll happen. But you know, it only takes one major failure to set everything back by a couple of years. But so far, so good.
I would say, yeah, probably a couple of years with other people. I'm not so sure with Musk. I mean, blowing Pad 39 to pieces, and he was back up and running in very, very short time, and he's blown several of these up. So I think with other organizations, if it was a government organization like NASA or ESA, and they had a major
inquiry, and
there'd be huge numbers of inquiries, etc. As long as no individual is harmed or killed. And obviously we've got this Japanese tourist, this Japanese multi-billionaire who's paid for the Frank Borman experience, as it were, and the Bill Anders experience, the Apollo 8 circumlunar flight. And we were talking just before we came on air about Frank Borman and how much he hated that. Bless him, throwing up. The reason we were talking about him is because he's the oldest of the surviving Apollo astronauts at 92. Recently reached that milestone, and it's not going to be easy, but again, don't bet against Musk ever achieving this. And it may look a bit ugly, as you know, Terry was saying, it looks a bit like a grain silo, and we've said this, and the kind of silvery stainless steel look is probably not to everyone's taste. It looks a bit like a Tintin rocket or something from a sci-fi movie from the 1950s, but if it works, it works. You're not going to knock the guy, and he clearly knows what he's doing. There's a lot of involvement globally with some of the material science, and I was talking to one of the material science companies earlier this morning who are directly involved in what SpaceX are doing. So there's a lot of work going into this, and to see 31 of those Raptors fire up is going to be something else.
Yeah. You
so
can only wish them luck.
Oh, you can. Moving on now. Next story. I'll let you, Terry, take this one away because this is a cracker. I love this.
Right. That's only probably because you can't pronounce the names, and probably I can't either. But it was an amazing story. 2 14-year-old Indian schoolgirls have discovered an asteroid, an interesting one. And I'll try their names. Radhika Lakhani and Vaidehi Vicaria. Apologies if I get that wrong. 2 secondary school students in Gujarat in India. They were taking part in a citizen science project called the International Astronomical Search Collaboration. And that uses data from major automated search programs. In this case, it was the Pan-STARRS set up in Hawaii and the Catalina Sky Survey in Arizona, which are both surveying the sky, broad swathes of the sky on a regular basis, basically to detect near-Earth objects that might possibly pose a danger to the Earth. And there's obviously major computer algorithms set up to try and analyze all this data, because there's so much that no one individual could do it. But as well as that, you can join in this citizen science project, and that's what they did. And why didn't the algorithm pick up this particular object? Well, because all of the surveys of the sky are basically separate little panels, if you like, and there's a little gap in between each panel, if you like squares on the chessboard. And the object that they found actually spent some time in the gap between 2 of these adjoining panels. So the algorithm didn't pick it up, but the good old human eye, or eyes in their case, did. And they spotted this thing that the computers had missed. It turns out to be quite an interesting one. It's what we call a Mars crosser. In other words, its orbit will take it inside that of Mars, moderately close to the Earth, close enough to be classed as a near-Earth object, although it won't be anywhere near the Earth for quite considerable time. It's officially called at the moment asteroid 2020 OE6. But they will, in the future, assuming the orbit is confirmed, they've already got quite a lot of information on it, they'll be invited to suggest names to the International Astronomical Union. So I have no idea what they have in mind for it. But it just shows you what can be done. It's great to see not only young people involved, but 2 girls involved, because we're all aware of the sort of the imbalance in gender in all aspects of science. So full kudos and congratulations to them for what they've done. They will, as I say, eventually be able to name it, and it may have some sort of an Indian name. There are various conventions that you have to follow in naming something, but it's really, really great to see young girls doing something like that and encourage other people to join in similar projects.
Couldn't agree more. I mean, this kind of touches my own heart a little bit, because we did a lot of work like this a few years ago with the Faulkes Telescope. So two 2-meter telescopes, one in Hawaii, one in Siding Springs, and it was all about kind of engagement with schools and STEM. And we got involved, and between myself and some of my colleagues, we were working on it in Italy. We found quite a number of asteroids, some of which we've now got proper confirmations on, Jupiter Trojans, etc. But it was great working. We were working with a 16-year-old girl at the time, Hannah Blythe, and it was just amazing kind of seeing her go from, I don't know what I'm doing here, to being able to identify these objects by eye. And as you said, the algorithms, they are very good, but they don't spot everything. And the naked eye, this is where projects like the Zooniverse, for example, have excelled in having human interaction and having hundreds of thousands of people in some cases classifying galaxy shapes or asteroid tracks, etc., and even down to Earth-based projects where they've got cameras all over places like the Serengeti in Africa looking at different species. And it's one of those things that machine learning and artificial intelligence, yes, it's getting better, but having a pair of human eyes is great. And as you said, having 2 young girls, especially as you said, there's such a dearth. It's about 7% in engineering circles, which is female at the moment, and it needs to be changed. I'm really pleased that in a lot of the space sector, we've got an office, my company has an office up at the Harwell Space Cluster near Oxford, and there's a really good gender balance there, probably about 50-50 even. So really good to see this. Moving on to our next little story. That was a cracker. I love that one. This one's a bit sadder. So all of you James Bond fans out there may recognize this. This is not a post-Pierce Brosnan GoldenEye scenario. This is not a shot from the film set. This really happened. So Arecibo is the 2nd largest radio telescope in the world. It was the largest for many years until China built the 500-meter FAST telescope, which is a bizarre one because they built a very similar design to Arecibo in a natural hollow in the Chinese countryside, evacuated everybody from anywhere near it, cleared all the towns to reduce the radio interference, because these things are so sensitive. They can I'll go into that in a minute, how sensitive they are, but they're incredibly sensitive. So they basically cleared out the town in China, but then they've moved in another town for tourists. It's just bizarre. Anyway, so Arecibo, this is a 305-meter wide telescope in a natural bowl in Puerto Rico. It was seen in the James Bond film. If you've seen the Jodie Foster movie Contact, you'll have also seen it in that. It was used in that. It's been used a lot for some of the SETI work. It's really famed for sending out some of the most amazing deep space signals. It's got a radar capability as well. So it's able to image asteroids when they come relatively close to the Earth and get very detailed radar images on those. It was the first telescope to spot ice on Mercury's poles. So it's got this real history of doing incredible science. And unfortunately, they had an incident on August the 10th where one of the cables snapped and basically trashed about 100 meters of this telescope, which is what you can see in the image there. It's devastating from a scientific perspective because it's probably going to take quite some time to repair. And obviously now it's given the Chinese a clear run with the FAST telescope. Saying about sensitivity, I worked for a short while a few years ago on the Square Kilometre Array, which is the most sensitive radio telescope on Earth, will be. And that's basically hundreds of separate telescopes all kind of conjoined using a technique known as interferometry, where you can merge the signals. And that's capable of detecting a mobile phone signal or an airport radar at up to between 10 and 30 light years. So you can imagine the sensitivity on these things when you've got to be able to filter out everything. Somebody using a mobile phone, you're generating 10 to the 24 times the amount of power of the average object in the sky with a mobile phone. washing machines, cars, anything that generates any form of radio signal, these things can pick up. So this again goes back to Starlink and SpaceX. You know, that thing's consuming so much of the radio spectrum in the sky. It's going to be horrible. I don't know if you've got any more thoughts on this, Terry, but it was just, it was that.
The trouble is, there was already some doubt about the future of that telescope because it is very old, and there are lots of others now, like the SKA and ALMA and the fast one you mentioned in China. And this has obviously been upgraded several times over the years, but it's quite expensive to run, and there was some doubt already about the future funding. So this certainly won't have helped it. Now, it was one of the secondary cables that snapped. We don't know why. It literally just was under tension and gave way. And then there's a sort of a whiplash effect, which is what caused all that damage. So I suppose if there was a fault in the cable, they might be able to claim from the supplier on that, or I don't know whether they're covered by insurance. But it really would be a shame if that magnificent telescope with such a great history beside it was allowed to sort of go into some state of lapsed operation. It'll take quite a bit of money and quite a time to repair it, but it's still a very powerful telescope. It just looks straight up, obviously, because it's suspended in a natural hollow in the mountains, but you can steer the signal that you're either sending or receiving by moving some of the detectors over the dish, so that in effect you're slightly pointing it in different directions. Still a very powerful observatory, and it would be great to see it operational again.
Yeah, not fully steerable, as you're saying. It's moving the secondary, in effect, to give you that kind of limited tracking capability, unlike, say, Jodrell Bank, for example, or the Deep Space Network, which is obviously tracking everything in the far solar system, which leads us quite nicely onto our next story, which is Ingenuity. This is a cracking little mission, part of, obviously, the 2020 launch that happened quite recently. Terry, I'll let you take this one.
When I first read about this, I thought they must be joking, a helicopter on Mars. Because apart from anything else, Mars has an incredibly thin atmosphere, the same as the Earth's atmosphere at a height of 100,000 feet. But obviously they've allowed for that. It's extremely light. It only weighs about 1.8 kilos. It's riding, I was going to say piggyback, but piggy under, if you like, on the Perseverance rover. When it lands successfully, as we all hope, after a while, they are going to detach this from Perseverance itself, and it's going to make about 5 short hop flights. Now, it's not a major scientific experiment. It's mainly a demonstration of the possibility in the technology. It will have a camera. It has a camera on board, and it will take some images. So the plan is that it will make about 5 relatively short hops of about 90 seconds, and it will fly up to about 1,000 meters away from the main rover. It obviously has to stay in contact with that to be able to send the signals back to Earth. But it's a demonstrator of what will be possible in the future. We're all familiar with drones now flying around and the fantastic images they can send back. This, of course, will be a completely autonomous, unlike a drone, which you control from your hand controller or from your base back in America when you're flying one over the Middle East. That's another story altogether. But this thing will have to be completely
you don't do
autonomous.
that.
I didn't say that. And we all know about it. Because of the delay in the time signal from Mars back to Earth. So this will operate on its own. It will be pre-programmed to go and look at A, B, and C and so on. But when it's actually flying and imaging, it will all be done autonomously when it's there. So all you can do is say, fantastic idea, great way of just discovering an awful lot more about the surface of Mars, an even better resolution than the MRO, for example, a reconnaissance orbiter can do. And it will be paving the way for future ones with greater payload, more scientific instruments, greater range, and so on. So can just again only wish it luck.
Yeah, and this is the thing, they powered up because so obviously in the trans-cruise phase now between Earth and Mars, so the intention is that they're going to try and power up now every 2 weeks just to go through the systems checks, etc., while it's on its way to Mars. Obviously anything can go wrong even on the cruise phases. They're going over there, they've got to do mid-course corrections. There'll be all sorts of different maneuvers and power-up cycles and check cycles before they go through entry, descent, and landing. What's interesting about this is if this proves to work, then it will effectively open the floodgates to potentially other missions, you know, either out to the farther solar system, going back to Titan perhaps, and, you know, there's been mooted plans of putting a submarine and an airship on Titan. So it will be really interesting to watch it. Sorry, my battery just seems to have told me that it's running out, so I'm just going to quickly plug that in before that dies. Yeah, so that'll be interesting to kind of monitor and watch this. What's also interesting is that future human-based exploration, when it eventually gets to Mars, maybe in 2030, 2035 kind of timescale, having this capability alongside the astronauts, you know, with the moon, for example, going from Apollo 15, 16, 17, they had the rover, which vastly extended the capabilities and scientific range and reach. If you've got these kind of controllable drones, and as Terry said, this one is autonomous and is going to be effectively under its own AI control from the surface of Mars itself. But once you've got astronauts on the surface, they will have the ability to fly these and check out regions and check out potentially things like sinkholes or ice formations or caves, all sorts of things that may be deemed to be too dangerous by the mission controllers on the ground, but they could fly a drone into a cave and check out what's in there. And I think this is going to really open up the floodgates to potentially the future for human exploration as well as autonomous and robotic exploration. I'm really excited about this. Hopefully it's going to work. So sorry about the battery thing there. I just had to move my laptop a little bit before, and obviously cable disconnected. Brings us on to our next story in terms of failures and battery failures in particular, quite neatly. Rocket Lab. So they had their first mishap quite recently. Peter Beck, much like Elon Musk, who runs Rocket Lab, he's one of these people that doesn't give up. And he's kind of bounced back with something really ambitious here. We've not seen missions to Venus in quite some time. We had the European Space Agency's Venus Express, which was a kind of really nice low-cost spin-off from the Mars Express missions, and gave us some really detailed cloud and infrared observations and radar observations down to the Venusian surface, showed that potentially there's still active volcanoes, that, you know, confirming everything that we knew, that Venus is literally hell on Earth, as it were, but hell on Venus. With surface temperatures enough to melt lead, hotter than most ovens that you get on the surface of the Earth, atmospheric pressure that would crush anything out of existence, acid rain, contrary to what we thought in the 1950s when everyone thought, oh, it could be a, you know, potential Earth twin, as it were. It's not. It is a really, really bad place. I love this mission. Terry, I know this is a story you picked up on. What's your thoughts on this?
The interesting thing is that while, as you say, Venus is hell at the moment, as Patrick Moore used to say, if you were on the surface, you'd be simultaneously roasted, crushed, and corroded by the sulfuric acid rain. So, no, you're not going to be sending human beings there for quite a while. The interesting thing is that we think that Venus in the distant past actually was a much more habitable place with liquid water and reasonable temperatures. And that is always a possibility then that life could have evolved. Now, we're 99.9999 whatever certain that no life could survive on the surface at the moment, certainly nothing as we know it. But higher up in the atmosphere, at a height of about 30, 40, 50 kilometers, the temperatures are quite similar to the temperature and pressure of Earth's atmosphere at sea level. So if life ever did evolve there in the past, it could possibly have survived in the higher levels of Venus's atmosphere. And that is what this mission is going to explore. Not to land on the surface. In fact, the main craft is not going to enter the atmosphere. It's going to send a couple of smaller little drone type things into the atmosphere and search for life. Well worth doing. Venus is the nearest planet to Earth in the sky, in the solar system. It's also Earth's twin, if you like, in terms of size and mass and density and so on. And what we can learn from what has happened to Venus is actually very salutary, because the reason it is so hot is not just because it's closer to the sun than we are, but it's had a runaway greenhouse effect. And the temperature is much, much higher than it would be if it was just due to its closeness to the sun. So with the possible dangers of runaway greenhouse effect here on Earth, it's something that's well worth exploring. And of course, search for life elsewhere in the solar system is always one of the great priorities of space exploration.
Absolutely, and you see, obviously this one isn't going down to the surface. The last missions, and indeed the only missions, and this is the irony, in that you go to Mars, and the only people who've ever successfully landed on the surface of Mars have been the US missions from Viking onwards. Apart from 15 seconds of Mars 3 back in the early 70s with the Russians, where basically they landed and then the camera died, and then that was it. The mission was over. But Russia have had an inordinate amount of success with their Venera missions to the Venusian surface. They had color cameras on the surface taking images, and it was really hell on earth. You only have to go back to some of the Venera images to see that. But they were doing that almost 50 years ago, and it is quite remarkable that it's one of those things that we always kind of head outwards towards Mars, but very few of the missions. There's been hardly any missions, as I said, apart from probably Venus Express and some of the flyby missions in years now. Japan obviously have got orbiting cameras, etc., as well, taking some really beautiful images around Venus at the moment. But exploration of Venus hasn't really taken off, pardon the pun, and whilst nothing can survive on the surface, there is obviously a big push to see what's subsurface on Mars, obviously protected by the radiation and, you know, some of the temperatures on Venus. It's not saying never. It probably is very, very unlikely there's anything subsurface alive or you know, existing at this time. But it'd be really interesting at some point in the future to send probes to the surface of Venus to possibly dig down and look, you know, if in its distant past it was habitable and there was a potential for life, and some of that's been buried subsurface and possibly not eroded or not crushed out of existence. It would be really interesting to see if there was anything there. I'm not saying that there is, but it's one of those things that never say never, I think.
Yep.
Moving out to the far distances, far reaches of space now. Earlier this year, everyone got really excited because Beetlejuice started dimming and everyone thought, oh, here we go, it's going supernova. So all the national press was saying, oh, it's going to go pop. And it potentially could have. We don't know. At its distance, we're not going to find out about it for about 600 years, even if it has gone bang. If it does go bang, it's not going to kill anyone. It's not going to be horrific. It's going to be as bright as a full moon. You'll be able to see it in broad daylight for a few weeks. It's going to be really nice to see. The constellation of Orion will never look the same again. But it was dimming, and now they've kind of proven what was causing that dimming. And it all comes back again to the greatest scientific experiment in human history, which has been the Hubble Space Telescope. And we were talking about Arecibo earlier and how important that is. Nothing compared to Hubble. Hubble is just in a kind of league of its own until the James Webb gets up there. And I know that, again, this was a story you picked up on, Terry. So.
Yep. Yeah, we do like, ordinary astronomers like you and me, like images, we like photons. The radio telescope produces a huge amount of data, but it's all digital. You can't look at a picture until you sort of program something to create one for you. The thing about Betelgeuse is it's totally mind-boggling. It's what we call a red supergiant star. Giant star evolving very quickly, already near the end of its life, and it is so big that it's hard to comprehend. If you put it for our sun, is it would swallow up the orbits of Mercury and Venus and Earth and Mars and the asteroids and all the way out to Jupiter. It's just unbelievably big. And as you were saying, it is eventually going to go supernova sometime within the next million years, we think, which is a blink of an eye on the astronomical timescale. What was really interesting, as you say, was in October, it started fading and it kept fading. Now, it's slightly a variable star, but it never faded as faint as it got in the early part of this year in 2020 as it did before. That never faded as much as that. And as you say, people were wondering what is going on. Is this a precursor to the explosion? So it took, as you say, the good old Hubble Space Telescope to sort this one out. It had been imaging Betelgeuse on a regular basis in ultraviolet, which it can do because it's up above Earth's atmosphere. And it detected actually some material being sent out through the atmosphere of Jupiter in the southern hemisphere in the ultraviolet. We couldn't detect that from the surface of the Earth. And what seems to have happened is that that material passed out like a sort of a big puff of breath. And that's, you know, you can hardly describe it. Huge space, but basically that's the analogy. And that material was very hot to start with, but it eventually cooled as it moved out away from the star and condensed into dust. So you had a huge cloud of dust, and it obscured the light coming from Betelgeuse, specifically from the southern hemisphere of Betelgeuse as we see it. And that shows you, as you were saying, just how remarkable the Hubble Space Telescope is. This object, although it's so big, it's 600 light years away, and yet the HST was able to resolve the image. And as you can see there, the brightest part is in the northern hemisphere, and the southern hemisphere is darker. So it was simply Betelgeuse itself expelling a cloud of material which condensed, became dark and opaque, and temporarily blocked some of the light coming from the star. And then eventually it dispersed and partly drifted out of the line of sight. And Betelgeuse is back to its normal appearance, but it's very well worth watching. You start to see it again in the very early mornings, just about now, just before the sky starts to brighten with the dawn. And I always have a look to see just whether it still does its normal brightness or not.
And we'll put that into context now. What we're talking about is the Hubble Space Telescope, which is 450 kilometers above the Earth, with a 2.4 meter mirror, 2.4 meter in diameter mirror, imaging the surface and essentially coronal mass ejections. And if you know what a coronal mass ejection is, these things are spectacular even with our own sun. You don't want to be anywhere near one of these. These things can like eject material out millions of kilometers. There's some great images of ones that are literally like 1 million plus kilometers in length. Even prominences on the sun. I image the sun quite regularly, and some of the prominences are the distance between the Earth and the Moon regularly. So something that literally is the size of most of our solar system out, as Terry said, to the orbit of Jupiter, kicking out that length, that amount of material, you don't want to be anywhere near this. But to have a telescope with a 2.5 meter mirror, 2.5 meter diameter mirror, 450 kilometers above the Earth, imaging something that's 600 light years away. Now, you put that into miles. Voyager 2 and Voyager 1 have been basically traveling away from the Earth at probably one of the highest speeds any human object has ever flown at since 1977. And they're about 18 light hours away. So not even a light day away. And that's since the distances, if you're not into astronomy, these distances just blow your mind. Even if you are into astronomy, these distances should blow your mind. It's a big star. We see it quite clearly. But 600 light years, being able to image that level of detail, it's one of the reasons why the Hubble in my opinion, can never die. Once those reaction wheels go and those gyros go, somebody needs to send up a repair mission. They do not want to be doing anything else. And that really leads on quite nicely to our next story, which is in standardizing satellites. This is obvious. This is so obvious that I'm amazed this is even a news story, but it seems to be that they've finally cottoned on to the fact that if you've got a computer, you've got USB ports on it. You plug a USB device in, it'll fit into a USB port. Or you've got VGA, or you've got HDMI, you've got standards across most electronics and most devices. In terms of the computing buses on satellites, you've got, again, a pretty well-defined set of standards. And whilst there's a lot of bespoke work that goes on, a lot of the CubeSat fraternity will buy off-the-shelf components or radiation hardened versions of off-the-shelf components and standardize them. However, in terms of reducing the debris up in space, which is one of the key things that everybody's talking about at the moment, there really isn't a standardized bus to kind of grapple onto. And I know with the last servicing mission to the Hubble, they fitted a kind of grappling bar to the bottom of it so that it could be deorbited safely. I'm hoping they will never deorbit it. Throwing that thing into the bottom of the Pacific, to me, would be an absolute tragedy. It needs to be serviced or at least bumped into a higher orbit to such a point where we have the capability to resurface again, either with another shuttle, something like, Sierra Nevada's Dream Chaser, something that can take astronauts up to it and they can service it. Because that mirror is perfectly viable. The cameras can be upgraded. We've proved that on multiple servicing missions. The gyros, the reaction wheels can all be upgraded. The solar panels can be upgraded. The mirror itself is still delivering incredible results. And this, even with the ELT and all the other huge telescopes that have been planned on the Earth's surface, it's one of those things that, yes, you could probably send up a servicing mission, cost as much as sending up another Hubble. But at the moment, they're not planning on sending up another Hubble. And the James Webb at $8 billion is still delayed and still overrunning. So it's one of those things. I'm really passionate. And I know every astronomer in the world loves the Hubble. It's the most prolific scientific instrument in history. It's generated more scientific papers than anything. Nobel Prize award-winning stuff. So what we got with this standardization of satellites is that finally someone said we need to put standard grappling fittings onto satellites, either for deorbiting or, as Northrop Grumman, who are a big defense company, are doing right now with the MEV-2. They had the MEV-1 success quite recently, where they managed to kind of resuscitate an old satellite, putting a refueling capability on it. I know that NASA Goddard SSCO Center is working extensively on a robotic refueling and servicing mission. This has got to happen now. In my opinion, all future large satellites need to have this capability on board. It's something that should have been done years ago. It's standardization of space. And in the past, you've had a lot of companies who don't want to do that. They enjoy this niche. We know how to do command and control. We know how to do servicing. We know how to do this, and we don't want the great unwashed, the masses doing this. But the commercialization of space now, especially with companies like SpaceX and Blue Origin, etc., it's going to happen. I don't know if you got any thoughts on this, Terry, but it's one of those things that we need to see happening, I think, moving forward.
It makes total sense. It's so expensive to put a satellite up there in the first place. And even with one thing that I forgot to mention, we were talking earlier about the mission to Venus. This is yet another private mission. And it'll be cheap compared with sort of NASA or ESA missions, only about $10 to $20 million, which is cheap for a mission, an interplanetary mission. But even allowing for the decreasing cost of sending stuff into space, it still is incredibly expensive. So it makes sense if something goes wrong, whether it's just a failure of a minor component or it needs some sort of an upgrade, to be able to service them there. And it's not the sort of thing that you necessarily need to send an astronaut up to do. It'll not be long before we'll be sending robots up to do that, to lock onto a satellite, insert something to upgrade it or repair it and so on, and then go on and do another one. So it makes total sense to do that. And again, it's interesting to see the private side of this space enterprise getting involved in that.
That's it. With the Hubble, it was always designed to be serviced by astronauts, but as you said, we don't have that. So if you can standardize these buses and standardize the interfaces to enable robotic resurfacing is going to be important. It's very important, actually, mentioning that Peter Beck's mission, the Rocket Lab's mission, is the first private interplanetary mission of any kind of degree, and the cost savings are just enormous. I mean, they're launching entire missions. They're quoting something like $5 million for complete autonomy on the mission. That's unheard of prices. It still sounds, and obviously is, very expensive to most people in the street, but you're looking at $10,000, $20,000, $30,000 per kilogram to launch a satellite, compared to even 10 years ago, where we're looking at $500,000 to $1 million per kilogram to launch the same kind of capability. The price is collapsing now, and this is where space is really going to take off. And we think hopefully the benefits to humanity are going to become obvious. Being able to do Earth observation monitoring of ice sheets, rapid response to dangerous areas around the world, and mitigation against natural disasters like volcanoes, tsunamis, all sorts of things. This is what satellites are giving us as a benefit. It's not just your TV. That is a almost decreasing market now, the whole satellite TV thing, but what satellites are able to give humanity is quite amazing. So it's one of those things that we need to see more of a cost reduction. We need to see more kind of solid business cases, but also people need to have a very high moral standards. They need to be able to deorbit, or resurface these things and not increase the debris mess that's up there already. So hopefully this is a good thing for the future of satellites. Moving on to our final bit now, looking up and what not to miss. We were both out looking at Perseids in the last few weeks. I saw a few. Terry, I know you saw more than I did from your wonderful dark sky location in Ireland. What else have we got to look forward to?
Well, I think since we were talking so much about Jupiter, it's hard to miss it, really. Apart from the moon, at the moment, it's by far the brightest and most spectacular thing in the night sky until Venus comes up, and that's not until just before dawn. So for most civilized human beings, i.e. excluding astronomers, Jupiter is the thing to look for. And it is still very spectacular. It's just past what we call opposition, so it's fading very, very slightly, but it's also visible now at a much more reasonable hour. Due south, round about local midnight, with Saturn just to the left of it, but Jupiter's by far the brighter of the two. If you have any doubt at all about sort of identifying it, at the end of the month, on 28th and 29th of October, the moon will be passing by it. So if you haven't spotted it, look on those nights. But just a very interesting thing, if we compare Jupiter tonight with tomorrow night, if you have a telescope and you look at it tonight, you'll see all four of the main, what we call Galilean moons, because they were discovered by Galileo over 4 centuries ago. And if you look tonight, round about midnight, from left to right, you'll see Ganymede, and then Jupiter itself, and then Io, and then Europa and Callisto, very close together. So you might need a bit more magnification to separate those two, but you'll be able to see Jupiter and all 4 satellites. If you look tomorrow night at the same time, you'll only see 2. What's happened to them? Well, they'll be simply behind Jupiter as we look at them. And if you keep looking through the night tomorrow night, you'll see Europa pop out from behind Jupiter, actually coming out of eclipse, because it will be eclipsed in Jupiter's shadow. You'll not see Callisto coming out until just about dawn, because it moves much more slowly. But it's just an interesting contrast. If you have a clear sky tonight and a telescope, look at Jupiter, 4 satellites, same time tomorrow night, only 2. They're still there, but 2 of them won't be visible. They'll be behind Jupiter.
And they're fascinating moons as well. If you've not looked at Europa or Io in particular, Europa and Io, they couldn't be farther apart in terms of contrast. Io's this volcanic world, active volcanoes detected by the Voyagers in the 1970s, and an intern basically at Jet Propulsion Laboratory doing some image processing was the first person to see that there was active volcanism on another planetary body or another body in our solar system with Io. And then Europa is just this gigantic ice world, made famous obviously with Arthur C. Clarke in 2001 and attempt no landings here. That will happen. There's missions been proposed like Europa Clipper and penetrators to kind of get through the ice layer and potentially look at subsurface oceans. So it's one of those things that even if they only appear as dots to you, as Terry was saying, you can see all 4 tonight and just 2 and Europa popping out tomorrow. It's one of those things, just in your mind's eye, kind of just remember how amazing these things are. That with Jupiter's moons, you've got one of them that's actually larger than a planet, actually larger than Mercury. So it's one of those things definitely don't miss. And as Terry said, just to the left of that, you've got Saturn. And then just to the left of that, as it were, you've got Mars. So it's one of those things that literally, if you go out to a nice dark sky location, you can see 3 planets with the naked eye at the same time in basically a line along what's known as the ecliptic, kind of a left to right thing, Jupiter, Saturn to Mars. And again, with the moon's position, that it can make for some fantastic photography opportunities. So don't miss that, definitely.
We'll be saying a lot more about Mars later on, because it will be really spectacular in October. If anybody really wants to see that happening, Europa will be coming out from eclipse tomorrow night at about 1:20 in summertime. And if you look at, say, 1:15, you'll only be seeing the 2 satellites, and then slowly brightening out as it comes out of eclipse over a period of about 5 to 10 minutes. You'll see Europa just appearing to the left of Jupiter as we would look at that in the sky. Your telescope may give you a different inverted image or whatever, but if you're using a telescope, you'll be used to that. And you can actually watch this satellite, which was invisible because it was in Jupiter's shadow, appearing, and suddenly Jupiter's got 3 of its 4 moons back. I observed many, many eclipses of the satellites of Jupiter in my younger days, and always found them fascinating, even though they're predicted and you knew they were going to happen. Just fascinating to watch.
It's beautiful as well. You've got some very experienced amateur astro imagers, people like Damien Peach, who's world renowned for his imaging, and even from the UK. And Jupiter and Saturn aren't well positioned for UK observation at the moment for astrophotography, so quite low down. But if you've got specialist equipment, infrared filters, for example, and a half decent sized telescope, a lot of the amateurs tend to use the larger Celestron and Meade telescopes. Celestron in particular is very favoured by a lot of the amateur astrophotography community. You can get some spectacular images. I mean, images like people like Damien Peach has managed to get surface details on all of the Galilean moons from his backyard in the UK with a telescope that you can buy off the shelf. So it's one of those things. It's a great fun thing to do, and they do contribute to real science as well. People like Christopher Gorat in the Philippines, Damien Peach, various other people all over the world are imaging the clouds, what's happening with the cloud belts, the shrinking in the Great Red Spot, which has been happening for some time now, looking at these moons and these occultations happening, for example, when they pass in front of stars behind, where you can see, with the larger telescopes, in particular the research grade telescopes, you can see things like the atmospheres of some of the outer worlds and how they dim stars in the background, things like Pluto even, for example. Some of the first observations to prove that there's an atmosphere around Pluto came from occultations, where it was passing in front of stars. So it's one of those things that if you're into observation and you want to get into astronomy, planetary stuff, you know, lots of people would show you spectacular images of galaxies and nebula, etc. But our own solar system is wonderful to look at an image as well. So
yeah,
important.
I remember observing Titan occulting a star. I can't remember exactly when, 30, 40 years ago, actually. I was on holiday in France at the time. So such a major event, I brought a telescope with me. But that occultation actually told us quite a lot about the atmosphere of Titan long before any spacecraft had gone there, because we were able to analyze the way the light dimmed and flickered and how it changed in different colors as it was transmitted through the atmosphere of Titan on its way to Earth. So as you say, interesting to watch, but also capable of delivering very, very interesting science.
Absolutely. And on that note, we will see you again in a fortnight, hopefully, and we're very much looking forward to that. It's been a really enjoyable show tonight, and huge big up and thank you to the Space Store team as ever, who do a great job in keeping this little show rolling. They do lots of other talks as well throughout the week, so don't forget to tune into those. I'll hand you back to Latch now, but once again, good night from me.
And good night from me.
Now, once again, a big thank you, Nick and Terry. Thank you if you tuned in for tonight's roundup. Once again, we'll be back in 2 weeks' time on the 1st of September, same time, same place on our YouTube channel. If you enjoyed this talk from Nick and Terry, please do share it with all of your space fanatic friends. I'm sure they'll enjoy the channel. Give us a thumbs up, give us a subscribe. And once again, a big thank you to you guys, and we'll see you again in 2 weeks' time.
Okay, bye.
Adios, amigos. Cheers. Bye.
Bye.